And here's where things will get a little, not necessarily more difficult, although they do. That's not my point, though. The complexity increases to such a point that you have to be very, very careful not to make mistakes. And it isn't that any particular thing you do is a complicated thing. There's so many things you have to do. Okay, there's so many steps to these problems. We're going to be rationalizing binomial denominators. So if I give you the following, 6 over root 3, that is not rationalized in the denominator. The denominator is a radical, which needs to be rationalized. But it's a monomial. And just to remind you what you do in a case like this, what you would do is you would multiply the top and the bottom of this expression by the radical you would like to rationalize. So what ends up happening here is you get 6 root 3 on the top, and on the bottom you have root 3 times root 3, which is merely 3. Then you can take that 6 and that 3. When I say that 6 and that 3, I'm talking about these two individuals. And since they're both coefficients, we can divide them and get 6 over 3 is 2. So you get 2 root 3. And that's basically what we did yesterday. Okay. What we're doing today is rationalizing binomial denominators. So the question becomes, what if I had 6 over root 3 plus 8? How do I rationalize that? And there's a way to do it. There's a way to multiply the top and the bottom of this expression by something so that when you simplify it, the denominator is a rational number. It will not have radicals in it. So, as a warm-up, let's simplify 4 root 6. Very similar to the one I just gave you, but now we're doing it in our note package. So we take 4 root 6. We need to multiply the numerator and denominator by the root 6. Simplify the denominator and then simplify further if we can by reducing coefficients. In the numerator I get 4 root 6. And in the denominator, root 6 times root 6 is, of course, 6. If you still need to say root 6 times root 6 is root 36, that's fine. Don't worry about that. You can do that. But I'm not going to spend time doing that or explaining that every time. The square root of 6 times the square root of 6 will simply give you 6. And now, just like the off-the-cuff example I started this lesson with, these are both coefficients, so we can simplify them. And 4 over 6 is 2 over 3, so what we get is 2 root 6 over 3. Piece of cake, yes? I hope? Okay. So, we need to multiply the numerator and denominator by root 6 in order to rationalize the denominator in that example. If the denominator is a binomial, this is the rule, and you'll see how it works in just a second. We need to multiply the numerator and the denominator by what's called the conjugate of that binomial denominator that we want to rationalize. The simplest way I can explain to you what a conjugate is without even talking about radicals or anything else these are conjugates. X plus 1, x minus 1 are conjugates. These are conjugates. X minus y, x plus y. Introducing some radicals. These are conjugates. Okay. Conjugates have that form. A plus B, A minus B. They're not negatives of each other, because if you take a look at 7 plus 2 and 7 minus 2, they're not negatives, right? 7 plus 2 is 9. 7 minus 2 is 5. Okay? So it isn't that they're negatives of each other. The first term is positive and the second term is positive, and then the first term is positive and the second term is negative. So what's the big deal about conjugates? Well, these are two conjugates that happen to contain radicals. And not only does each binomial have a radical, it's got two radicals. But would you agree it fits the pattern that I just talked about? Okay. So 4 root 6 minus 3 and 4 root 6 plus 3 are conjugates of each other. If I say, what is the conjugate of this yellow highlighted binomial, you will answer this blue highlighted binomial. If I say, what's the conjugate of the blue, it's the yellow. They're conjugates of each other. So, question 1, in the space below, multiply these two conjugates together. Now, this is going to be foiling things. So I'm going to have my first, which will be the product of these two things, and I will get 16 times 6. You with me on that? 4 times 4 is 16. Root 6 times root 6 is 6. My outer will be the product of these. So it's going to be plus 4 root 18. 4 times 1 is 4. Root 6 times root 3 is root 18. My inner will be the product of these. And I end up with negative 4 root 18. Which is nothing. I'll come back to that in a second, but my outer happened to be 4 root 18. My inner is negative 4 root 18, so when I add those together, I get 0. And then I'm left with negative 3. This is my last. Negative 1 times 1 is negative 1. Root 3 times root 3 is 3. I get negative 1 root 3. Or negative 1 times 3, which is just negative 3. So what I end up with is 16 times 6 minus 3. I end up with what I think is 96 minus 3, which gives me 93. You're in agreement on that? Okay. This 93 has no radicals in it. It is a rational number. Why did we get a rational number when we multiplied these two conjugates? Well, it's because my outer and inner canceled. Will that always be the case? That's one of the reasons. Let's go back and look at these ones that I gave you. If I FOIL out x plus 1 times x minus 1, I will get x squared. My outer will be minus x. My inner will be plus x, and then I will have minus 1. So my outer and inner cancel. If I FOIL out x minus y, x plus y, I'll get x squared plus xy minus xy minus y squared. My outer and inner cancel. And I'm not going to simplify this one because it's very similar to what we just did. But the bottom line is when you multiply two conjugates, you don't have to FOIL. You can FLA. There's no outer and inner in the end because the outer and the inner will be opposites of each other. So what you end up with, in the most general sense, is this, don't you? If I ask you to multiply out a plus b times a minus b, you end up with a squared minus b squared. But think about this. If a contained a radical, this little bit of business will get rid of the radical. And if b contained a radical, that will get rid of the radical in b as well. So because you're left with what we call in Math 10 a difference of squares, even if the things we are squaring were radicals, they will no longer be radicals because we're squaring them. Okay. So what do you notice about the product of two irrational conjugates? The product is rational. And if we are trying to rationalize a denominator that is a binomial radical, then this will accomplish it. We just have to do the same thing to the top and the bottom. So simplify. So you cannot simplify root 3. You can't. And the only coefficient we have on the top is a 5, and on the bottom there's a 2. You know what? Even if this were 15 plus root 3, that 5 and the 15 are off limits. You cannot cancel something unless it's a factor. So there's nothing apparently to be done here except, well, I'm going to rewrite the question first. 5 over 2 plus root 3. We need to multiply the top and the bottom by 2 minus root 3. Why? Because 2 minus root 3 is the conjugate of that denominator. And we know when I multiply the top and the bottom by the same thing, I'm not changing the value. And we know when I multiply 2 conjugates, I'm going to get a new denominator that doesn't have radicals. And that's what we need to do, rationalize the denominator. Furthermore, and you're going to have to practice and get used to this, I really abandon the idea of FOIL here, and I go to what happens when I multiply 2 binomial conjugates. I get a squared minus b squared. That's all I have to remember here. You can call it FLA if you like, but all I'm going to do is square 2 and subtract the square of root 3, which is 3. A common mistake here, everybody, would be to treat the 2 the same as you treat the 3. But the 2 is not root 2. It's 2. In its own right, it is 2. So when we square that 2, it becomes a 4. But the root 3 is not 3. It's root 3. When we square it, it becomes 3. So what we are left with is, on the top, 5 times 2 minus root 3. The bottom of this is simply 1. So our answer is 5 times 2 minus root 3. And that's it. If I figure out what that is, just for kicks, 5 times in brackets 2 minus the square root of 3, I end up with this decimal approximation. And if I evaluate what this is, it's a little more work. 5 divided by, in brackets, 2 plus the square root of 3. I get the same answer. Okay. So they're equivalent. They're equal to each other. Some of you might be questioning, and it's a normal question, should we multiply that 5 through? And what I will tell you is that starting in the next unit, any mathematical expression, whether it contains pure numbers like this or maybe algebraic expressions, should always be left in factored form wherever possible. And the way I would explain the reason to you right now is I would say there's nothing to be gained by multiplying it out. Sometimes there will be something to be gained by multiplying it out, and then we proceed down that path. But we're graduating to the point where it's not always do this, 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 and this. You do certain things for certain reasons. And there's nothing to be gained by multiplying it out. Let's try another one. 12z over root 8z minus 3. I don't know if anybody has noticed, but occasionally I put a little hanging line coming down off of that radical to indicate that it actually goes over the z. I need to multiply the top and the bottom here by the conjugate of the denominator. And you know what I would say to you? Well, I don't know. You may not be able to follow this. I'll come back to my thought in just a second. So let's FOIL out the bottom. We always FOIL out the bottom because you're going to get your rationalization happening. And you're going to get 8z minus 9. So I don't know how many of you will really fully appreciate this, but we'll talk about it a lot in the next unit. When are you allowed to cancel things? Forget about this question. When are you allowed for a fraction to cancel something on the top with an identical thing on the bottom? It's a very specific case, and I've talked about it a couple times lately. No one remembers? Georgia?
When they're both like coefficients or like they're like the same form?
There's a word for the thing when they're both factors. Okay, so you're only allowed to cancel if things are factors. This is maybe the rationalization why you leave the numerator in factored form, just in case there's a factor on the bottom that matches a factor on the top. I would say we're pretty much done here with the exception of one thing. So on the top, there is only the factor of 12z and the factor of 8z, root 8z plus 3. Remember that a factor is something that is in brackets by itself, multiplied by other things that are in brackets by itself. In the denominator, there's only one factor, so nothing can cancel. There is something we need to do, though. Anybody notice what we have to do here? We shouldn't leave that root 8z the way it is. We should say root 8z is 2 root 2z. Right? That root 8 is 2 root 2, so we can extract that 2 and have the following 12z, and then in brackets 2 root 2z plus 3 over 8z minus 9. Only because I'm here to teach math, not just this math, would everybody agree that z must be greater than 0? Okay, looking at the original expression, we have radicals there. However, looking here, you cannot divide by 0, which means 8z minus 9 is not allowed to be 0. And this isn't something you need to worry about, but when the time comes for me to officially teach this to you, I'll be able to say, remember, we've seen this before. This is not allowed to be 0. And that time might not come till Math 30. I don't know. We'll see. Which means if we solve this, z is not allowed to be that number. So those are your restrictions. What does this mean? It means if this is a number line, and this is 0, and this is 9/8, z is allowed to be anything. I better be careful here. This should be greater than or equal to, because you can take the square root of 0. Z is allowed to be any number indicated by that number line. It can be 0, it can be greater than 0, it just can't be 9/8. Let's try one more. 12 over root 6p minus 3. I hope you see that despite how things get typed and printed, that square root is not over the p, it's only over the 6. So I need to multiply top and bottom by the square root of 6 multiplied by p plus 3 . What do I get on the bottom? That. Just think about it for a second. Don't just write it down blindly. I need to take root 6p times root 6p. Root 6 times root 6 is 6. P times p is p squared. And then for conjugates multiplied together, it's minus the second thing squared, and that will be minus 9. Here is a perfect example of why we do not want to multiply that 12 in. The bottom has a factor of 3 in it. And 12 has a factor of 3 in it. If you multiply that 12 in, you can probably still keep track of it, but if you multiply that 12 in, then you're only going to have to factor a 3 out anyway to cancel. You certainly do not need to write 12 as 3 times 4. However, I want to explicitly show you why 3 is a factor. And I've said to my math 30s a number of times this year, when we're dealing with trigonometric expressions and when we're dealing with logarithmic and exponential functions, I've told them I wish that they got rid of a whole bunch of topics in Math 20-1 and we just spent all of our time learning about simplifying expressions and when you're allowed to cancel stuff. It's that important. You are only allowed to cancel something if you see it in brackets multiplied by the rest of the stuff which is in brackets. So that's what we're left with, and that's the final answer. 4 root, whoops, be careful here, 4 brackets root 6 times p plus 3. I don't know if you've noticed, I'm putting a little bit of air between the root and the p. I think it's important that you don't try to crowd them together. Over 2p squared minus 3. Can I cancel this and this? No, because those numbers are not factors. Why do I know they're not factors? Because they're not in brackets by themselves multiplied by everything else. Can I cancel this 2 with this 4? Well, although 4 could be written in brackets by itself multiplied by everything else, the 2 is not, because it's not multiplied by the 3. If it were this, which it's not, go ahead. So bottom line is we are done. And then the mother of all rationalizations, we have a binomial over a binomial. Let's rewrite it. I always think it's a good idea to rewrite it. I think trying to write our work, attaching it to that little tiny printed thing is difficult. So we have 3 root 6 plus root 5, and then 2 root 6 minus 3 root 5. Double check all of the numbers as you rewrite it. So we multiply top and bottom by 2 root 6 plus 3 root 5. We're multiplying top and bottom by the conjugate of the bottom, by the conjugate of the denominator. 2 root 6 times 2 root 6 is 4 times 6, minus 3 root 5 times 3 root 5 is 9 times 5. Now, and again, math at this level is just as much about understanding why you do things as opposed to what to do, okay? As opposed to the math. Every example we've looked at, I've said leave the numerator in factored form just in case something cancels. Well, now we have to be adaptable. Let's multiply the top out to see if it is factorable and to see what simplifies. Sometimes you have to do that. You can't just say, well, it's in factored form, let's leave it. Let's multiply it out and then see if we get something even simpler that's factorable. So we have to do a FOIL here. First is 3 root 6 times 2 root 6. 3 times 6 is 6. Root 6 times root 6 is 6. My outer will be 9 root 30. So my first is multiplying this and this. My outer is multiplying these two. My inner is multiplying these two, which gives me 2 root 30. And my last is multiplying these, which gives me 3 times 5. Can everybody verify those 4 products? In other words, don't just blindly write down what I'm writing. Double check them. But I think they're fine. So on the top we have 36 plus 25. 35, 36 plus 35, which is 71. I feel as though I wrote something down wrong. Yeah?
Shouldn't it be plus 15 and not 35? Because it should be 3 times 5.
Thank you. I hope you will believe me when I say I know it's that 3 times 5 is not 35. I just forgot to put brackets, I guess. Thank you. Better? So 36 plus 15, which gives you 51. So we get 51 plus 11 root 30 over whatever 24 minus 45 is, which I think is negative 21. So, this is just the way it is sometimes. I said we should multiply this out just in case we get something simpler that's factorable. We didn't. But that doesn't mean you can erase everything we've done and go back up to the top of the screen. This is our answer, and I would be happier if you threw that negative out in front. I don't generally like a negative in front of a fraction, but I like it more than putting a negative in the denominator. Like 51, 11, 21, there's no common factor. If this was $12, it's not, so don't change it. If it were 12, then I could factor a 3 out. You can confirm that 3 times 17 is 51. Georgia. And on the bottom you have 3 times 7. So if this were a 12 root 30, you could get rid of a 3. But there's no common factor there. So bottom line, that is our answer. And that, I believe, is our final question, isn't it? Okay. So 1 to 5 on the next page. You are rationalizing these beasts now. You certainly don't have to do every question.